Good morning friends, welcome back to Panika Tutorials. In the last video, I have discussed about longest job first scheduling algorithm with an example. I hope you have watched that video. If you did not watch that video or if you don't know that concept, I request you to go back and watch that video and come back to this video. In this video, I want to discuss about longest remaining time first scheduling algorithm with an example. So I request everyone to watch the complete video for better understanding. Any scheduling algorithm have two important parameters. One is the criteria and another one is the burst time. Coming to the longest remaining time for scheduling algorithm, the criteria is burst time. The process which has the highest remaining burst time will be given priority to dispatch to the running state. Now coming to the mode, it is preemptive scheduling algorithm. In the last video, we have discussed about the longest job first scheduling algorithm, which is a non-preemptive. Sometimes to confuse you, instead of giving it as a longest remaining time first scheduling algorithm, they may even give it as preemptive longest job first scheduling algorithm. If they say preemptive longest job first scheduling algorithm, or if they say longest remaining time first scheduling algorithm, both are same. Okay, now with this knowledge, let me solve this example using the longest remaining time scheduling algorithm. To solve any scheduling algorithm, we need to first find the Gantt chart. Always the Gantt chart will start from 0 units of time. Okay, now we have ready state and we have the running state. Okay, look at the table and check which process has arrived at 0 units of time. Only process P1 has arrived at 0 units of time. Okay, now if you have only one process which is there in the ready state, that will be dispatched to the running state. Okay, so from ready state it will be dispatched to the running state. As it is a preemptive scheduling algorithm, we will execute the process P1 for 1 unit of time. Okay, its remaining burst time is 2 units. By that time, we will check any other process has arrived to the ready state or not. Yes, at 1 unit of time, process P2 has arrived at the ready state. Its burst time is 1 unit and process P1 remaining burst time is 2 units. So you need to look at the burst time of each process which is there in the ready state and running state, and which one has the highest remaining burst time will be given criteria. So P2 is 1 and P1 is equal to 2. So P1 has the highest remaining burst time. So again it will be given chance to execute. So it will be executed for one more unit and its remaining burst time is 1 unit. Okay, and P1 is equal to 1. At that time, any other process has arrived? No other process has arrived, because the process 3 will arrive to the ready state at 3 units of time till it is 2 units. So only P2 and P1 is there. Now if you look at both the process has the remaining burst time as 1 unit, there is a tie. If there is a tie, we will go for first come first serve scheduling algorithm. Is it clear? Are you able to understand? Meaning is that the arrival time will be considered to give the criteria, means priority. Now look at between P1 and P2. P1 has arrived at 0 units of time, P2 has arrived at 1 unit of time. So which process has arrived first? P1. So that will be given high priority. So P1 only will be executed for another 1 unit of time. So it has completed its entire CPU required time. So it will be go to the terminated state. So process P1 is done. By that time, process P3 has arrived and it needs 3 units of time. So look at the P3 and P2, which process has the highest remaining burst time? Process P3. So that will be dispatched to the running state. Okay, so it will be run for 1 unit of time. Okay, so its remaining burst time is 2 units. By the time process P4 has arrived, because it is 4 units, it is mentioned here as process P4 will arrive to the ready state at 4 units of time. So process P4 has arrived, its remaining burst time is 2. Now look at the P4, P2 and P3. Which one has the highest remaining burst time? Process P4 and process P3 has the same burst time and they are highest. Now again there is a tie. If there is a tie, we will use the first come first serve scheduling algorithm. Meaning is that which process has arrived first will be given criteria. Process P3 has arrived first as compared to the process P4. So it will be executed for one more unit of time. Its remaining burst time is 1 unit. Now if you look at process P4 has the highest remaining burst time. So process P4 will be scheduled to the running state. Okay, so process P4 will run for 1 unit of time. Its remaining burst time is 1 unit. Now if you look at all the three processes have the same burst time, then again there is a tie. We will look at the first come first serve scheduling algorithm. Among P2, P3, P4, which one has arrived first? P2 has arrived first. So again there is a context switching. Process P4 will come here and process P2 will go to the running state. Process P2 will run for 1 unit of time because it needs only 1 unit of CPU time to complete its task. So it is done. Okay, and once it is done it will go to the terminator state. Now both the process P3 and P4 needs 1 unit of time. Again there is a tie. If it is a tie, we will look at the arrival time. Process P3 has arrived first, so it will be dispatched first to the running state. It will be executed for 1 unit. Okay, now its remaining burst time is 0, so it has completed the task. Okay, are you able to understand? So process P1, P2, P3 has completed. Now process P4 needs one more unit of CPU time to complete its task. As only one process is there in the ready state, it will be dispatched and it will be executed by the 9 units of time. So we got the completion time of all the process. Once we got it, we can easily compute the turnaround time, waiting time, response time, average turnaround time, average waiting time. First let me find the completion time of each process. Process P4 has completed 9 units of time. Process P3 has completed 8 units of time. Process P2 has completed 7 units of time. Then process P1 has completed 3 units of time. P1 has completed 3 units, P2 at 7, P4 9, P3 8. Yes, good. Now turnaround time. Turnaround time is equal to completion time minus arrival time. So 3 minus 0 is 3, 7 minus 1 is 6, 8 minus 3 is 5, 9 minus 4 is 5. Now we need to compute the waiting time. The waiting time is equal to turnaround time minus burst time. So 3 minus 3 is 0, 6 minus 1 is 5, 5 minus 3 is 2, 2 minus 5 is 3. Okay, now response time. If it is a non-preemptive scheduling algorithm, the waiting time will be equal to the response time. But however, this scheduling algorithm is a preemptive scheduling algorithm. So the response time and waiting time may not be equal. So how can we compute the response time? It is the time difference between the process when it has first entered into the running state minus arrival time. Look at the process P1. It has arrived first into the running state at 0 units of time and it has arrived at 0 units of time. So 0 minus 0 is 0. Process P3 has arrived to the running state at 3 units of time. However, it has arrived to the ready state at 3 units of time. So 3 minus 3 is 0. Process P4 is 5. 5 minus 4 is 1. Process P2, 6 minus 1 is 5. If you look at these two process, waiting time and response time is not same. Okay. Now, once you got the waiting time, turnaround time, usually in any competitive exams, they will ask you to find the average turnaround time or average waiting time. Let me discuss how to compute the average turnaround time. Average turnaround time is equal to sum of all the process turnaround time by number of process, which is 3 plus 6 plus 5 plus 5 by 4, which is equal to 9 plus 5 is 14, 14 plus 5 is 19, 19 by 4, which is 4.75. Because for 4 is 16, you will have 3, 3 by 4 is 0.75. So you got the average turnaround time. Now let me discuss to compute the average waiting time. It is same. Average waiting time is equal to sum of all the process waiting time by the number of process, which is 0 plus 5 plus 2 plus 3 by 4, which is equal to 10 by 4, which is 2 point, okay, you will have 2, so 2.5. Is it clear? So this is the way you need to compute the average turnaround time and average waiting time for a given schedule using the scheduling algorithm. I hope it is clear for you. If you have any doubts, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.